So our first speaker in this session is Yasin Elbin Almaini from Siemens EDA, where he's a product architect. The title of his talk is Leveraging FPGA Optimized Equivalence Checking for Security, Safety, and Assurance Standards.
Presentation.
No? Changed it? Sorry. The title of the talk is Questa 1 SFV. Sorry. Yasin is doing 2, and I've introduced the wrong one, but that's one later if you want to go to that one. Just to tempt you. Yasin, well, presumably your bio stays the same. Yasin is a product architect for formal tools at Siemens EDA. Over 25 years experience in EDA software development and support process. Yasin has been guiding customers through hands-on product evaluations and deployments of digital verification technologies comprising simulation and formal. He holds bachelor's and master's in electronics and computing from the Institute of National Polytechnic in Toulouse, France. Thank you.
Thank you very much, Mike. Thank you for organizing this event. And I'm very lucky to be in this air-conditioned room. As the weather out there is pretty hot. So I'm very excited to share with you the news of Siemens EDA launching new products, next generation static and verification platform, which is part of the Questa 1 family. And as you can see from the first slide, the theme, the goal, the excitement of AI is all there. So this is a platform that will enable us using some of the AI techniques to provide faster engines, to make you faster engineers, and to facilitate fewer workloads. So it's a high-level presentation, so please forgive me for the brevity of what I'm going to talk about. But here's what I'm going to do. First of all, I'm going to talk about the why are we launching a new generation of EDA tools. And I'm going to tell you what it takes to address the why. And then I'm going to show you some examples of the new technologies and the features that this next verification platform enables. So what are we seeing in the industry in terms of challenges? I don't think you've seen this in many other presentations. When you look at silicon success rates, I think there is an agreement across the board that the rate is falling alarmingly rapidly. So only 1 in 7 chips achieve first silicon success, and many of them will have to go through a number of respins, and if you need more than 2 respins, the entire economics of that particular chip becomes in question. Not only are we seeing a decline in first silicon success, it's very common to come across schedule overruns. So many projects are behind schedule, and only 1 in 4 make it as per the plan. So we see that a lot in the industry. We also see, and talking to our customers, they all talk about productivity gap. And there are stresses over several factors within the design and verification cycle. As I just mentioned, the schedule. So no matter how many engineers you add to a verification project, you're still short of engineers, and you still cannot conduct all of the verification tasks that you want to perform and reach the coverage that you want to achieve within the prescribed schedule. And hence you've got schedule overruns leading to respins, which again, the major root cause of is functional failures. You all know about the complexity that's driving this productivity gap. So we tend to talk about software-driven architectures, software-driven requirements that add in to the complexity of the features we want to verify, but also the technologies that we're using make for new challenges. So for some chips, it becomes very, very challenging just to verify trivial stuff like interconnect when you've got a very large, either an FPGA device or a large ASIC. And last but not least, and this is probably good news for you, labor shortages. We just don't have enough people with the skill sets to do things like formal, to do things like UVM, and so on. So there's this aspect of the productivity gap. There's another aspect, which is we've got new and emerging requirements when it comes to verification. And one of them is security as well as trust verification. So many chips out there contain some kind of a security feature, but the security feature is only as good as the verification you perform on it. You need to make sure that it verifies. It's adding another thing to already a complex verification task. And like I said, we see that both in ASIC as well as FPGA. And to add fire to the oil, we've got increasing requirements from several authorities. So if you look at the DoD in America, Department of Defense, they are asking all of their defense agencies to make sure that they deliver evidence-based assurance for any security and trust features for any chips that they design. You've got vulnerabilities. More complexity means more potential for vulnerabilities, and those need to be checked as well. And as I said earlier, many chips now contain some kind of a security feature, if not a safety feature, depending on the target market you're in, whether that's automotive with ISO 262, electrical, medical, and so on. So all of this is driving the need and the demand for what's called hardware assurance. So how do you address these challenges? And you've probably seen this answer before. And I work with formal, so my answer is use more formal. Use more formal. Of course, that's not new. You want to increase your productivity with things that don't require you to spend a lot of time writing payloads. So deploy formal first where it applies. There's a lot of deterministic techniques that can generate assertions for formal, that can create the test bench, and so on. Make sure you get to those and you deploy them as part of your flow. But when it comes to things like design assurance, it's very difficult to get assurance using simulation. You need to demonstrate that you have enough payloads. Formal makes a lot more sense. So using formal to provide a proof positive flow makes sense, and that must be part of the answer to these challenges. And so taking this into account and taking the industry challenges into account and looking at the technologies that are emerging, and you've already heard this morning a lot of talks about AI and ML. So how can we come up with a solution that addresses these challenges using the EDA technologies that we have and upgrade them to take advantage of AI and ML? And if you're going to do this, and we have in mind that we have labor shortages, so we want to be able to put these tools in the hand of fewer engineers and enable them to generate more payloads without requiring a detailed skill set for those tools. All of this gives us a very great opportunity to come up with the next generation of EDA technology, and hence the idea and the product of Questa One. And so we have launched Questa One back in May 11th in Munich as part of Siemens EDA's user-to-user. It was relaunched again in user-to-user in Fremont. I think today there was another launch in India, in Noida, and I'm very pleased to be launching it here in the UK. And so here I give you Questa One SFV, so Questa One stimulus-free verification. So hopefully now that you get the idea of how we're taking the opportunity of AI, ML, and some of the challenges to create a new platform, let me tell you a little bit of what Questa One SFV provides. First of all, Questa One SFV is part of an overall initiative in Siemens EDA. The initiative is Questa One, and that refers to a branding, to a set of technologies to provide single platform for either next generation or multiple verifications in the same cockpit. And so you've got Questa One Sim, and I've got colleagues here in the room who can talk about Questa One Sim in a much better light than I do, as I'm a specialist in SFV. So that's giving you one single engine with breakthrough performance. Just talk to my colleagues and come to the booth if you want to know more about Questa One Sim. You got Questa One Verification IQ. That provides you with a common management system for verification and uses predictive AI to automate a lot of the tasks that you would normally do manually. Questa One Avery VIP, many protocols are available out there. You want to be able to verify, you don't want to spend time making those protocol VIPs yourself. Questa One Avery VIP provides that. And last but not least, the SFV piece, which is the stimulus free verification, and the part that I'm going to focus on in the remainder of this presentation. So, Questa One SFV, we're not going to reinvent the world. We're not going to reinvent the wheel. EDA has been out there for a long time, especially formal. And in fact, as part of Siemens EDA, we've already got Questa Formal. I don't know if there are people who remember the Mentor days and the Questa Formal days. That technology is there, is mature. You've got OneSpin, and OneSpin provide many key differentiators, very interesting formal apps that actually address some of the challenges that I've talked about, like security and verification. So obviously, we're not going to reinvent those. We're using the foundation of Questa One SFV, using these pieces of mature technologies. And so on top of that, we're providing a variety of possible analysis using formal apps. So you'll find that you can get to more than 20 formal apps all within Questa One SFV, whereas in the past, you may have to acquire them separately. And so now that we've got all of this mature technology, how do you make it ready to embrace the AI and the ML technologies? And so what we're having to do is, and again, you've probably heard this in other presentations, you need to modernize this environment, and you want to modernize it so that it is able to talk to things like LLMs, it is able to take advantage of ML technologies. And so we're having to modify the software architecture so that it is using modern software design techniques, like using protobuf, if you're familiar with software design techniques, which essentially decouple the implementations of various agents. And those agents are able to talk to LLMs in AI using an MCP. So if you modernize and you make your architecture microservice driven, it's very easy for you to go to LLMs. And that's what we've been doing with this. As you can see, the next layer is to provide an integrated verification environment with Questa One, which we refer to as Q1VE, Questa One verification environment. So that's roughly the architecture of Questa One SFV. I'm not going to go into the software architecture. We don't have enough time, but I'd like you to remember that, yeah, it's more than just reusing what we have. It's modernizing it so that you can connect it to various LLMs and take advantage of the AI and ML EDA opportunity. And so this is what we have with Questa One SFV, or SFV for short, all static and formal in one platform. That's the IVE. So I'll talk about that a little bit more in the next few slides. We're not expecting that everyone is an expert in all of these formal and static tools. And so obviously, we want to make the tool contextually aware. So depending on what you're focusing on in the design and verification flow, you'll get customized views to help you be more productive. And wherever we can use AI to assist you in achieving your goals, we will do that. And so you'll find we've got static assist AIs. So they are essentially AI assistants to help you with static verification. Formal assist, and I'm going to talk about property assist, which helps you generate assertions using generative AI. But we also want this environment to be scalable. And so we're adding some scalable formal technologies that allows us to do automatic partitioning, that allows us to do automatic black boxing to allow you to take things like formal and static from block level to higher, more complex designs. And we also want all of this to be easily available. Never idle is our mantra when it comes to licensing in Questa 1. And so limitless formal is that application of if we can use engines to run things faster and those engines are available, we would, no matter what the app is. So what's the IVE? Questa 1 Integrated Verification Environment. As the name suggests, and it's deliberate that it's derived from IDE, which a lot of you are probably using some kind of an integrated design environment as opposed to an integrated verification environment. So this is the same cockpit that provides all static and formal in integrated flows, and that's contextually aware. And so if you want an IVE, you need an IDE. The IDE is the Questa developer. So this is going to give you all the stuff that you would normally need in an IDE, a design browser, a smart editor, and then using this as the entry cockpit, you can run a number of integrated analysis and enable a number of flows. And again, so as you'd expect, if you've got an IVE, you're probably going to be doing a lot of your design and project management within this environment. So we provide that within the Questa developer. You can edit your files, you can edit your projects, the seamless integration with control systems, you can navigate through sources, and there's obviously a graphical visualization for all of this. Now, if you're going to use this IVE, and we go back, it probably makes sense that you use an IDE that a lot of people are familiar with. And VS Code is becoming a very common IDE that we come across in the industry. And so the IDE that we use and the IVE that we use is based on Microsoft VS Code architecture. So we've got two versions of this. You can either use a desktop app. It looks and feels exactly the same as VS Code, but it is wholly owned by and maintained by Siemens EDA. For those who would like to use VS Code extensions because they have their own, or perhaps they have their own workflows within VS Code, so we provide those VS Code extensions. You just put them in VS Code and you're able to run exactly the same functionality and get access to the same apps. Yeah, good question. Yeah, so the question is this VS Code editor compatible with other editors like you say Vim, Nano, things like that, Emacs, and so.
Everything that is LSP, that's the way to interact with smart. That's a standard. So
yes. Yes, there is an integration where you can always specify that the source code editor is something else. So like Emacs or whatever. But yeah, you probably need to talk to somebody from Microsoft VS Code to tell you, no, you don't want to be doing that. But yeah, fair enough. But it's more than an editor. So these systems, and again, I don't want to be doing the sales pitch for VS Code. It's got a lot more. If you get something like VS Code, you might get, I don't know, GitHub integration. You'll get thousands of extensions through Marketplace. So it was really opening up to a whole community that is significantly bigger than any other, yes, significantly bigger than any other editor you've come across before. So yeah, take a look. But like I said, I am not necessarily biased towards VS Code. As I said, we provide a standalone app that is not VS Code, but it's actually a Thea, for those who are familiar with a Thea app. Now that we've got the IVE, what kind of things can we do with an IVE? What advantage does it give you compared to standalone apps that you get, for example, in Costa Formal, that you might get in OneSpin? I'm going to take an example here. Suppose I'm a verification engineer. I want to run lint. Typical iterations that I go through is, how can I confirm that a lint issue is real? The lint tools are very good for identifying many potential issues. Some of them are real, some of them are not. Will not point to a particular functional bug. So the first thing is, within this environment, you've got smart editing, which gives you the ability to do on-fly linting. So you don't need to wait until the code is ready and run something that's fairly lengthy in terms of runtime and requires a lot of setup. So there's on-the-fly linting enabled within the tool. That might give you the answer. Syntax is correct for the RTL, so the code is correct by construction, and then you run full lint analysis. So when you run full lint analysis, you need things like, what sort of methodology do I want to apply? What sort of goal do I want to apply? Depending on whether you're at the beginning of the verification cycle, whether you're getting closer to a sign-off stage. And that gives, again, a trade-off between how much quality you have and how many issues you have to deal with. So that generates a list of potential issues. And as I said, some of them may be real, some of them may need further exploration, further diagnosis. One of the things we can do with an environment like this is actually run formal under the hood to check whether a lint issue is real or not real. Take examples like FSM issues. You may actually have a coding style, and the lint tool may actually flag that there may be a potential dead code in here. That's not something you can prove in lint without running formal. And so the type of synergy that you can have in an integrated verification environment is that on the fly, we can actually call the dedicated engines in formal to check whether it's a real dead code or it isn't. Typically, you could do that without an integrated verification environment, but it means going from one tool to the other. And so you go through this flow in here. These are some screenshots of the tool. Those of you who know VS Code will recognize VS Code, except that the theme is different. This is not the dark modern theme, this is the Siemens theme, but you can get your own theme and apply it if that's what you want. Some more screenshots showing highlighting and so on. Another interesting thing is that you've got seamless integration with EDA technologies like lint. So you don't have to quit to go to run the lint tool. The stuff that you see in this screenshot, that's actually running lint and displaying lint within the VS Code GUI. So it's actually using web GUI and using stuff that you're familiar with. So it really feels like an integrated verification environment. Now that I've talked about the IVE, I'll go very quickly and talk about AI. Again, you've got AI at the fingertips of the IVE. Typical question is, how can I get to clean code much faster? I've mentioned that lint can generate issues. We can actually now ask AI, and we've got a feature called Lint Assist Autofix, which will automatically propose solutions by asking an LLM. All of the LLM stuff is abstracted from you. All you have to do is provide what we call an endpoint. This is where the LLM lives, and it was set up, and that could be on cloud or that could be on-prem. And basically that will, so this is how you run it. You run lint analysis, you click on that yellow button. That will suggest a number of fixable issues. You tell it, give me a preview of what the suggestion is. You apply the fix, it will do it automatically, and we can rerun lint. Another thing that we do that you don't see in here is that we use equivalence check-in to see that the lint the fix hasn't broken any functionality. So again, that's something that you'd normally do in a separate step, but here it's all integrated. I've only got 30 minutes. I've already been warned. 5 minutes only left. There's tons of other stuff that we get as part of the IVE. These are some of the stuff that I've mentioned, like lint assist. Another one is property assist. This is a capability whereby we're actually using natural descriptions to say, can you write an assertion for this kind of description? Read and write are mutually exclusive, and boom, it goes to the LM and it generates an assertion. And we do a lot of integration with the formal backend. So we actually check the syntax is correct. We can also check it, whether it proves or not. And if it doesn't prove, we'll give you the waveform. And it's the waveform that is native to VS Code. You're not going to get some other strange waveform or other unfamiliar tool. It's all integrated within the same tool. And yes, I don't have time, but I could tell you a little bit more about all of the property assist stuff. While we treat the LLM as a black box within the software, we're also doing a lot of stuff on LLMs in terms of using techniques like prompt engineering, like RAG, retrieval augmented generation, to make sure that the quality of the assertions we get is good out of the box. For some assertions, it's as good as a human out of the box, but we get in there. If you start throwing complex stuff like AHB type of protocols and so on, we still need a human in the loop to take a look at that results. But the future's, you can see what it's going to look like. Eventually, more and more automation and more AI, and we'll trust more and have confidence in this. And with that, I've come to my last slide. I've talked about some of the challenges. I've talked about how this creates an opportunity to launch Questa 1. And I've talked about SFV, which provides an integrated verification environment with mature technologies that use AI to give you more productivity. Thank you.
Thank you very much. Bang on time. Thank you very much.